All right, so we're continuing talking about radicals. This is everything. So some different views at radicals and how that works for each one of these. So you'll notice the first one that you have a fraction inside of your square root or your radical. So this ends up being 3 times the square root of 81 over the square root of 100. And so then you are left with 3 times 9/10, because you're going to take the square root of 81 and the square root of 100, and it makes 9/10, which then it would become 27 over 10. I would rather you write it as a fraction, but if you wrote it as a decimal, it would be 2.7. Really rather you write that. I would probably accept a decimal. Just because you're multiplying by a fraction. But if you ever get something that's a non-repeating decimal, do not write it as that. You need to write it as make it be a radical sign. Let's look at the second example here. So you'll notice that you have now you're adding and subtracting some numbers with a radical sign connected to it. So just like with x's and y's, when you multiplied x times y, it became xy. But when you do x plus y, remember you can't add those because they're not like terms. So these are like terms. Every one of these, well, not like the whole thing. All of those are like terms. This one is not a like term. It has a square root of 7. So what we'll do is, just like if these were x's, like x, x, and x, and let's say that this was a y, let's just say, then you would end up with 17x, or 17 square root of 2, minus 5y, or 5 square root of 7. And this is as simplified as it gets. So if you had to find, like, I don't know, like, say perimeter of something and then it has some radicals with it, this is how you would simplify that. All right, looking at this, just like on the last lesson, we kind of broke it up and finding perfect squares underneath, and we wrote it like multiplying out. You can still multiply these within. So it doesn't matter how, if you want to go ahead and multiply those and make the square root of 60, and the perfect square inside of that is going to be 4. So square root of 4 times the square root of 15. So then that would be 2 square root of 15. You keep it as that. Or the other way that you can do that, I'll erase all of this and show you the other way. You could go ahead and write this as a square root of 4 times the square root of 3, just because it's a little bit smaller and you might see this perfect square a little bit better, and then times the square root of 5. This becomes 2. So you're at 2 times the square root of 3 times the square root of 5. And I can put these two together, so I have 2 square root of 15. Again, the same answer, but just a little different approach. Depends on your preference. And then the last one is a square root of 3/4. So here you're going to take this and you are going to find the square root of 3 and divide it by the square root of 4. Now, square root of 3 is not perfect, so 3 is not perfect, so I can just leave that square root of 3, but the square root of 4 is perfect, and it becomes 2. So 3 square root of 2. So that's basically it. So that's just kind of sort of adding on to already what you know about radicals. Again, that's really tough. Make sure that you know your perfect squares, or if you're not sure about a perfect square, look it up on your calculator and just do, 22 squared. Okay, making sure that that wasn't in that. All right, so it's not just factors. So I didn't just pick, 4 and 3 for 12. No, I picked 4 specifically because I knew that that was a perfect square. All right, so just be very careful about that. 6 and 2 wouldn't work because 6 nor 2 would be a perfect square when I'm talking about this here. All right, so just make sure you know that you know those perfect squares. So this is kind of sort of wrapping up our radicals. I know it's been a pretty fast paced deal for this, but we got to get through this and make sure that we kind of sort of hit this before the STAAR test or EOC.